we're going to talk about the tale of two services. We're going to talk about the context, again, what we built, it was a demo, and then how like we could actually use this internally. So the scenario is we had a great call with a potential client, and after that call, we had talked some things, we had tried to understand what problems they're facing, and they had said we would love to see a demo of some of the things you talked about, specifically as it relates to introducing a bug, both as an application developer and into workflows, identifying that there is a bug and then responding to that bug, fixing it, right? Fixing the problem. Core operational things and core things that you'd have to do if you were a platform team or if you're an application developer, right? Bugs exist. So, before we got into actually showing them this demo of those two scenarios, we kind of talked to centralized workflows a little bit. And the reason why is because like they were interested in actually centralizing their workflows. Like it's a common pattern we see at enterprises. You have if you've ever worked in GitLab, you'll probably remember the dot something dot GitLab dot YAML. In GitHub, we have shared workflows, which and actions, like you can write your own actions. And so what we talked about was the problems that we often see when you don't centralize some of the things, right? Some of the core pieces, especially as you start to scale out. So usually what happens is you have like team one and they build, all these workflows for Maven and then all of these workflows for Go. And then they have a front end service too. So they build all these workflows. And then so does every other single team, right? And it becomes this huge amount of duplication across the board. And this is painful. And so these were some of the things we talked about. We actually talked about real world experiences that we've seen in other areas where coming back from this and trying to like introduce a new fix because of a migration caused a lot of pain. It was a lot of hard work. It was a lot of technical debt to pay down, right? And so the way we kind of talk about the paved path to production and having centralized workflows, we see this as being something more like this, where there is, you view your shared workflows as really a product to your customers, and you view them as you have a platform team that owns them, right? But it's inner-sourced. And so realistically, like this upgrade path becomes a lot easier because they are kind of centralized and shared across the board. Where team one may use like the Maven service builds and the Go service, they may pick those two pieces out, but then they get the rest of the stuff like linting and testing and releasing and deploying consistently and attesting because they were interested in automated governance as well. That having that proof to go through the CAB process. Team two, maybe they use a Maven too, but they also have Python and they don't use Go, right? But then there was a third team, and this is where we talk about like the flexibility, right? Like, yes, it's a paved path to production, but if you want to trailblaze and you want to get your machete out and you're on the hiking trail, it's not really a hiking trail, so you chop down all the trees as you go, like that's also okay too. And so team three, they use Go and they're a low-level systems team. So they actually decided to use Rust. They had to build their own Rust build and deploy pipelines, but they got to inherit the other shared workflows that existed. And then later on, they could share those back, intersource them, and those can be used by others. So these are kind of like the mental model we kind of painted for them as we talked to those things. And then we, of course, talked about, our view, our POV on platforms, how we've seen it work really well and how we've seen things can get improved. So that leads me to like, what did we actually build, right? And so for that, we have, again, two scenarios that were mentioned. The first scenario is the application developer scenario. And for that, I'm going to pass it off to Jarrett.
Alrighty, good morning, everybody. Let me go ahead and get my screen share up. Okay, you guys able to see that Backstage template? Okay, cool. So the first scenario that we introduced basically starts with I'm an app developer and I just got a new service up and running through a starter kit. For us, our starter kit was these sequence of Backstage templates. So we started out with the Golang template to create a Golang repository with just a basic application in there. And then from there, we moved on to the app onboarding template to get it onboarded to the platform. After that, we ran through this Honeycomb onboarding prereqs and Honeycomb onboarding templates to go ahead and get onboarded to Honeycomb so that we can start emitting our telemetry there and start making useful queries and visualizations. And so we've got our starter kits, we are onboarded to the platform, and now as a developer, I want to introduce a feature into production. So I merge my code in and I have it hidden behind a feature flag. And the way that we implemented this feature flag, we did it using the flag backend and the Open Feature SDK. And what that looks like here on this deploy YAML for our application, if we scroll down here, we can see that flag D is running in a sidecar container. And flag D works to both store and serve the flag, which is actually the flag itself is codified here in this config map, in this JSON file, and its value is based on this default variant attribute. When this is set to on, the feature flag is enabled. And then in the actual application, the way that we use that feature flag is we start off here in the main.go, and we initialize an open feature provider, it's called, using flag D, which will serve as our backend. And then once that is initialized here in this hello handler, we can initialize an open feature client, which will by default use that backend. And then we can use the open feature SDK to evaluate our feature flag and then make decisions in the code based off of its value. And so for us, when that feature flag is enabled, we basically just have a 1 in 10 chance of failing an HTTP request to simulate a real bug. Um, and the way that we were creating traffic to actually see if this feature flag worked and simulating a bug was using a K6. Oh, it looks like it's not up there. 1 second. Code K6 was using this K6 performance test. And K6 makes it really easy and convenient to set up some performance testing. Basically, we just have to set up these scenarios and then these functions. And so basically what's going on here is we have two scenarios for this perf test. We have high load, which has 100 VUs, which stands for virtual users, making requests for a duration of 1 minute at an interval defined in the high load test function, which as you can see here is every 0.1 seconds. And then we have another scenario called laid back, where it's 10 virtual users making requests for 10 minutes every 1 second. And so we would enable our feature flag to introduce our feature into production, and then we would then begin seeing that errors would begin to crop up once that feature has been introduced. And so once those errors start to crop up, we would expect the SLO for latency and availability to be triggered. And so if I come back over here, this is what that SLO is. Hello, down, I'm up. And this is using an SLI called endpoint is available and fast, which basically means we are able to both reach that endpoint and do it under a certain duration of milliseconds, ensuring that it is both available and fast. And if we were to exceed our burn down budget for this, we would expect to receive a trigger to send us a message here in Slack to let us know that we are in fact exceeding our error budget. So now as a developer, I introduced my feature through a feature flag. Errors began to happen. I was notified about those errors. And so now I can go back and use the traces to identify where exactly the error is coming from and begin to solve the problem. And yeah, so that's mostly the scenario we set up for the microserver side of things. And I'll throw it back to Adriel.
Awesome. Thanks for that. So that was a really good, like, how do you do this stuff as an application developer? How do you have a delightful experience? If you are curious about the starter kit / keep going kit, that was built out for, there's a recorded demo for that. So you can definitely get more information. Also, you can just go play with it if you want to. It's in Backstage, right? So the second scenario for the potential client was doing that same process, but treating it from the workflow side of the house, right? And so for that scenario, I'm going to pass it off to Sam.
So we have a dedicated repo that we broke out for shared GitHub Actions for our demo project. And this was an example of our build and test workflow that we're consuming in our demo application here. And it's semantically versioned and pinned by Renovate. And what we were doing was introducing an error into this workflow. So we have query that we have in Honeycomb, and these errors that we have, these workflow errors were produced by an OTel. We have an OTel collector running that creates traces from GitHub events. So this query was showing all the errors that we were getting for our workflows. And drilling down into one of these traces, like this was for the build and test workflow, we can see that it erred. So we went about creating a trigger in Honeycomb. And so it's anytime a pipeline fails, and we were just grouping by like anytime the count was greater than 0 for a specific version of a failed workflow. We are looking for conclusion failure, and then anytime a workflow started with our shared workflows repo. And yeah, just grouping by the reference workflows and service name. So that would produce a query that would show there were 10 instances for our shared workflow for the build pipeline that failed. So we could go back and pinpoint which release version was causing that error. And it sends, like Chair was saying, like a notification in Slack. So it lets us know that the build workflow failed and then for the specific version. So we can go ahead and resolve that issue. Liatrio?
Awesome. Yep. So that's like super valuable too, because it's like, well, what if you know, you just merged in your pull request because it's a dependency and you went about the rest of your day, but you didn't catch the failure for 5 hours later, right? Well, guess what? The platform team did catch the failure because they got alerted about it. So all these things are just showing kind of the interconnectivity of the SDLC, right? And how all this stuff operates together. Of course, again, you can play with that too if you want. You can see these things locally. And people want this stuff. Like there's lots and lots of questions in the industry about like, well, how do I trace my workflows? And additionally, it's not just about failures, but it's about latency and build times, right? Like one of, I think Honeycomb came out with a really good, like the only developer productivity metric you should actually care about, and it's build times. That was what they said. So it's a really good blog post. Posted in the channel somewhere. But realistically, like if you have a platform team that owns the builds, right, that are sharing these workflows with others, you do want to understand how long these builds are taking. And over time, if your builds are starting to increase in size, because that's what they do, right? Like, and then we acknowledge that, and then we go, you know, fix it, make it faster. This allows you to do that more quickly. It even allows you to, again, set budgets. You can use those same kind of principles for SLOs, SLIs on the workflows as well. So that was what we did for the client, right? We kind of connected a lot of the pieces that we had in place, and you know, I think it went pretty well. So, any questions, comments, thoughts, curiosities?